My name is Leah Sloan. I'm the Director of Professional Development here at CodeHS, and I have with me Mark Dozier. He is a Customer Success Manager here at CodeHS, and we have an amazing university student panel here. This is going to be a great discussion. Just a couple of logistical things. First, we have a Q&A. If you have questions, you can put questions in there. The chat is enabled for sharing good vibes, introducing yourself, just sharing any, anecdotal type of things on the side, which is really great. So to our fun fact, if you said, this is still shocking in the computer science education world, if you said 5% of high school students take class before they graduate high school computer science, you would be correct. That's something we hope to change, right? So I'm going to turn it over to Mark, and let's kick off this university student panel.
All right. Thank you, Leah, and thank you everyone that's joining us today. Again, I think I echo what Leah said. What an amazing opportunity to actually hear from the students, right? We get so focused on the teaching part and then the tools of the teaching, but how is this affecting the students, right? Like, I mean, I'm a former teacher. We'll kind of get in my background a little bit, but part of it is you wonder, okay, they did great in my class, but after that, what happened and what could I have done over? So just to give you guys a quick look at how this is going to go, we'll introduce ourselves, and then I'll kind of do like a panel style questions for each of our college students. And then at the end, hopefully you guys came with good questions that you can kind of come back and use that advice with your own classes. All right, so me, as Leah said, I am a customer success manager here at CodeHS. I'm based here in Austin, Texas. Previously, though, I did teach for a really long time. If you can count 15 years is a long time. Most of that was at Chicago public schools, and then my last 3 school years, I was at a private school in Chicago. And those last 3 years, I taught computer science to pre-K through 8. So we're talking kids on iPads all the way to kids transitioning into high school. And then joining us today, we have, first of all, our college students that are here. I need to know, how did Dave convince you to show up on a Saturday in the springtime? I need to know his secret, but if you guys don't mind, we'll start with Jacob, and maybe have you introduce yourselves and kind of tell us your background.
Hi, I'm Jacob. You could also call me Jack. I'm originally from the Chicago area, and I am at school in SUNY Binghamton University in upstate New York, studying computer science. And I last summer I had an amazing opportunity to be a software engineer intern at CodeHS.
Yeah, thank you for that. We were lucky to have you, by the way. Charles, we'll turn it over to you.
Hi, I'm Charles. I'm currently a senior at Oberlin College. I'm originally from Oakland, California. I also had the opportunity to intern at CodeHS. And to answer your question, Dave bought us lunch one day, so I had to do this. He's such a nice guy.
I always forget, it's not much, it doesn't take much to bribe a 20-year-old, but I'm well past that age.
One milkshake.
Maybe some extra ramen. All right, and then Annie, I don't believe was able to join us today.
I'm here. Sorry, I was a couple minutes late.
So
I had
sorry.
some technical difficulties getting on, but I'm here now.
No, not at all. So glad to have you here.
Thank you. My name's Annie. I'm a freshman at Georgetown. I'm studying business, so I'm kind of like the non-CS major perspective here. And I can't call him Dave. Mr. Kleinhans was one of my teachers in high school when he worked at Fenwick.
Oh, awesome. I was actually the customer success manager for Fenwick when Mr. Kleinhans was still teaching there.
Oh, wow. I didn't know that.
Yeah.
That's awesome.
Yeah. And our final panelist is Sebastian. So Sebastian, you want to go ahead and introduce yourself?
Sure, of course. Good afternoon, everyone. I'm Sebastian Dela Cruz, born and raised in the city of Chicago. I went to high school also at Fenwick, and Mr. Kleinhans was a very good mentor and teacher to me while I was there, and he reached out to me, so I was really graciously accepted the invite for this morning. And for me personally, I am currently a biobank research coordinator at the University of Chicago, where I'm also doing my master's in biomedical informatics with a concentration in healthcare informatics. And I also serve part-time in the United States Army Corps of Engineers as an operations officer.
Oh, wow. What an impressive resume. I feel like we should have another panel just for kind of some of the things that you're involved in. But again, to our university students, I really appreciate you guys taking the time and looking forward to just kind of getting your view of not necessarily CodeHS, but just the computer science from the teaching and learning aspect. All right, so our first question. So looking back on your computer science journey, and I know we're all in different places in that journey at this point, but if you can kind of walk us through, when did you first get exposed to coding, and then kind of what that environment was like? And let's start with Jack.
Hi. So coding for me was, I stumbled upon it. I was in my freshman or sophomore year of high school, and I had a Mac, and I saw there was this app called Xcode, and it looked really cool. And I opened it, and I was able to get like a virtual simulated iPhone on my screen, and I thought that was awesome. And then really quickly, I learned that I can create like a text box in a project, and then click a play button, and all of a sudden I'll see that text box with my name on it in my own app. And from there, I was really it was so exciting to me to be able to build things, and then I pivoted to building things with Arduino. I always found at the start that it was really rewarding to be able to see like the fruits of my labor and be able to like have tangible, like, this, I made this, and that was pretty awesome.
It's amazing. I think it reminds me of this poster that I used to have in my classroom, which is basically, be a creator, not a consumer. And it sounds like you took that first little bit of knowledge and said, hey, I can do this, this, and that. Let's keep it going. I love that. Yeah, let's go Charles here.
I first encountered like actual programming. So computer science generally, I think my first exposure was I played a video game for the first time and instantly fell in love. And I was like, how is this possible? How does this work? But in terms of actually programming, I joined a sort of programming boot camp put on by an Oakland organization called the Hidden Genius Project. And so it was just a setup for people that usually wouldn't have access to computer science to get their foot in the door and learn the ins and outs of how coding and coding languages and the industry in general works. And so my first thing I ever programmed was actually Carol on CodeHS in JavaScript. And it was the same satisfaction of like, solving a logic puzzle or a difficult math question, except I could see my solution doing something practically on the screen, kind of like Jack, actually. It was a Dr. Frankenstein moment. It lives, it's alive. And that was really, really exciting to me. And so from then on, I was kind of hooked. I knew that that's what I wanted to do.
Great answer. Yeah, the tangible part of it, I mean, you don't get that in all your other subjects. It's all kind of theory, right? Like, maybe economics, you're not actually out there doing it, or if it's history, is kind of static, whereas, hey, I can put something on the screen that I created that was in my brain like 2 days ago, and now it's there. Love that answer. Annie.
Yeah, my stories are not as like cool and crazy discoveries as what we just heard, but I did some like super basic coding on like things like Scratch and stuff in grade school, so I kind of like was aware of what it was. And then in high school, I took Mr. Kleinhans's classes, Computer Skills for Business, because I'm a business major. So my CS is kind of focused more on like Excel and like data analytics and that kind of stuff. So that's when I was more exposed to it. And then I've taken similar classes to that this year as well.
All right, excellent. And then let's round out this question with Sebastian.
Sure, of course. So it's a little bit funny how it started for me. Growing up when I was little, I was a very big fan of video games, so it was always something I got interested in as well, just seeing like the ins and outs of how like coding works, how like one character moves from the screen to the other. And when I was in high school, I met Mr. Kleinhans, and he recommended that I take his intro Python class. And that's from there, that's when I got started, as well as doing AP computer science as well in high school, and just doing it on my own time as well. And I also really thank my older sister a lot, who definitely more so works computer science on a day-to-day basis, as well as being a great mentor and teacher, as well as Mr. Kleinhans.
Excellent. Thank you. All right. So this is a great question. What are you doing today that involves either coding or computer science, or even taking that farther, computational thinking, I guess, which is what the foundational skill is being taught. Let's start this time with, let's start with Charles.
Right now, my big computer science activity is wrapping up my CS degree, since I'm graduating in about a month. But on the side, I tinker with mostly game related stuff. I've been doing a lot of research in how to create maps and mods for some of the games that I really like. And then generally, and this project's a little bit further out, but I'm working on a personal website just to keep information about what I'm working on, and a little resume, and maybe some nice pictures of myself.
A little portfolio building, nothing wrong with that. Let's hear from Annie.
Yeah, so I'm a business major, but specifically one of my majors is operations analytics. So I've taken kind of the intro classes right now that are a lot of Excel, pivot tables, things like that, like a lot of data visualization. And so I'm going to keep going with that. I will take an intro to Python class, but I have not yet. So definitely more on the business kind of side of it.
All right. Sebastian.
It's interesting for me, although I don't directly work in the world of computer science. I would say I use it a lot in now my day-to-day basis. My role as a research coordinator, I'm definitely doing a lot of crunching numbers, working with data sets that involves a lot of computer science and coding to simplify that. I remember working a lot extensively with Python while I was getting my first academic paper published, working with these massive data sets. As well as within my master's program, there's a lot of just the ins and outs of different kinds of computer science, looking at the theory as well as putting into practice. And then also, as well as my time within the Corps of Engineers, we definitely do a lot of computer science, definitely more so on the broader scale. A lot of it's automated with our with the different kinds of devices we have, but it's pretty cool how we put into practice, things in the real world, kind of like how architects do. So we'll use surveying tools, and then we'll put that into the computer and code it on how to lay out and make our own maps and things like that.
Wow. Leah, I mean, I'm sure you're thinking, this sounds so amazing, right? Like, I don't know about you, but at this part of my life or my, educational career, not involved in projects like that. So that's a great answer for what you're doing today that involves computer science. All right. All right, so let's make your teachers feel proud about themselves. What were some of those positive takeaways from those coding classes or coding related classes that you took in high school or even before high school? Let's start this round with Jack.
So some of the positive takeaways I took away from from my high school classes, you're saying? CS class?
Exactly. Mm-hmm.
So my high school CS class was like the first time I really learned the fundamentals of the basic structure, the building blocks that we use in across the board for all coding, like your loops and your conditions. And I didn't have the opportunity to use CodeHS in my school, and it was a little tougher. But being able to like sit with my professor and learn those fundamental building blocks, and then build like a game of Hangman on top of it, or something like that, was a really positive experience that I like take with me today, for sure.
Yeah, thank you. And you know what, Jack? I just realized we didn't give you an opportunity to answer the previous question. So if you want to double
Oh,
up
do you like
here,
me?
yeah,
Yeah,
if you
yeah,
let us
yeah.
know
So,
how you're using it right now.
Yeah, so computer science today is very much a huge part of my life. I'm a senior, about to graduate in May, from Binghamton, with CS, and so that's like I'm just like finishing up my school. I'm taking a really cool project management class where we're kind of going away from the technical side of CS, but like how do you manage a team as a project manager? Like if you had a team of programmers, which is a really cool thing. Um, Additionally, I am, of course, like I've had an amazing opportunity to be a course assistant for the data structures and algorithms course taught by the program director of CS at Binghamton, which is like awesome. So every week I lead a lab section and office hours for like 5 hours a week. And then outside of that, I've been tinkering around with JavaScript and doing like 3D graphics in JavaScript. I'm having fun with that.
Awesome. Love that. And thank you for coming back to that question for us. Okay, so in terms of challenges and, going from this is how we were taught in high school, this is what I learned in high school, this is how I was prepared. What were some of those challenges you saw taking it to that next level in college? And for this, let's hear from Sebastian first.
Sure. I definitely have a lot of insight on this because for me, I was never in specifically within a CS program, but I definitely did work a lot with CS. I can definitely speak a lot for my master's program specifically. So I come from a more medical and clinical background, so slash pre-med background. And for example, in my master's program, a lot of people come with that background as well. And the thing about that background is not most people don't have any coding experience, if at all. So I can remember clearly my first few quarters in my master's program, you had a lot of these pre-med people just absolutely struggling with the most basic kinds of coding because it was something so new to them. But it was nice for me because I had that background, thanks to Mr. Kleinhans, and just from other people within high school, I was able to draw back within that and help with my classmates and peers. So it was something I learned that, what was it? Definitely within, especially with my master's, I'm not sure, maybe the other students can talk about like undergraduate classes. There's definitely very much a higher and quicker standard of learning. You're definitely not having your hand held and going through these definitely what at times difficult coding questions, even for me. And it's just a lot of just your own self-discipline and working towards understanding and doing your best, even if it doesn't work the first time, just doing what you can to figure out that problem. A lot of it is just, I can draw back my time in the military. A lot of it is just, you have a massive challenge. You have no idea how you're going to get through it, but you just take a step back, make a plan, and then try your best. And if that doesn't work, you try something else.
Love that advice and love that reflection too. I really appreciate that. Let's hear from Charles.
Some of the new challenges, I think, are stuff that's kind of typical to all university classes, larger expectations, larger projects. You're expected to have more independence from what you're learning in class and do your own research. But specifically, I've definitely noticed that as I got further and further away from high school, the classes that I'm learning and the topics that I'm learning in computer science have gotten more and more conceptual rather than like physical or practical. Like for instance, in my freshman year, I took an intro to Python class, or that's the beginning of the CS track at Oberlin. And then from there, we moved to discussing data structures. We used a specific language, but we spoke about them in abstract. All the way to now, one of the last classes I'm taking is it's called Theory of Computation, and we're not doing any programming at all. We're talking about specifically the theories behind what computers can and can compute. And so all of these classes I felt have been equally valuable to my understanding and my study of computer science. But it is a marked difference from how I started, which is explaining the ins and outs and the syntax of a specific language, and going to, here is how you mathematically represent a Turing machine, the basis for, pretty much all common computation. And then also things like being given projects to manage, more group projects, and just larger stuff to work on overall, which has actually been really, really satisfying, but definitely a little bit harder.
And just a quick follow-up, do you have a preference there? Like, I know you talked about previously starting with more concrete things and now kind of getting into the abstract.
I think at the beginning of this school year, I would have said I greatly preferred the practical stuff, but I've actually really liked this theory of computation class. Not because I think, like, if I were to look at this from purely like a what am I going to use from my classes in a career standpoint, the practical stuff is definitely closer. But getting like a whole picture on computer science is, I think, super valuable to just using it outside of a specifically career context. I really like what I've learned in how it's shaped like aspects of my life that would seem to have nothing to do with computer science. And I think that the more you learn, the broader your study on it, the more that comes to sort of the front.
Yeah, I think everyone here would agree with that. Annie, can we hear from you on this question?
Yeah, absolutely. So I think the biggest thing that I've seen between high school and college classes, and also just between like my last semester of like very intro class to like what I'm taking now, is the transition between being told exactly what you're going to do versus now kind of getting an overall problem. Okay, go solve this, make your own models. Like I'm doing a lot of work in Excel. So my high school class, my first semester class last semester were a lot more, okay, first step, put this equation in this box, then do this, then do this. And then as you keep going, kind of that transition to, okay, here's this big question, use Excel to figure out how to solve it. And kind of as someone was saying earlier, like you just have to try something and see if it works versus kind of that you're so sure because you were given exactly the steps of what you were going to do in what order to solve the problem.
And then do you find there's more collaboration or less collaboration between like high school and college and with the other CS students?
I definitely think that there's more in college. I think that it's a lot more, I have a lot more group projects. Georgetown, the business school, is so huge on group projects. So I have a lot of things that I'm working with people. And then also with what I was saying, when you have a more overarching problem that you're trying to solve, there's a lot more collaboration, because if you're following a list of steps, like you're less likely to need to talk to your neighbor about how they're thinking about going about something because we're told how to go about it. So once you get that kind of bigger picture assignment, you're more likely to collaborate, share ideas of, okay, wait, I was thinking about going about it this way, but maybe your way makes more sense, kind of a thing.
Yeah, that seems more realistic for the real world, I would say.
Yeah, I agree with that.
Sebastian, would you like to weigh in on this one?
I believe I already did.
Oh, I apologize. Okay, so then it looks like we're up to Jack.
Yeah, so I wanted to go off of the point that Charles was making about the practical side versus the conceptual side. I think in AP computer science, I felt like it was very practical. Like I was doing Java, I was learning how to build these practical applications and programs. And when you go into university CS classes, you kind of enter the conceptual side. And I think where it really succeeds at its purpose of like teaching a good CS education is when they can take the conceptual things and they can give a practical explanation of why you're learning this and how you could apply it. Because, for example, like theory of computing, I took it last year. We were building these things called automata machine, like state machines. And we learned how you can like sort a list of numbers using a state machine. And that is something that you can take this like very conceptual thing and apply it to solving a problem that is tangible. Another thing I wanted to talk about was when I was originally like talking to the past program director of CS at my university. She's like, why do you want to go here? Why do you want to learn CS? I was like, because I want to learn how to code. I want to learn how to build things. And she told me like, well, you're in the wrong place, because the purpose of CS at a at university now is, how do we solve problems? How do we take these conceptual things, and like the coding will come second. You can learn how to code something in 5 different languages that all accomplish the same thing, but how do you take these problems and be able to solve them and apply all the concepts that you've learned to tangible problems? So that was something that was very new to me going into college. Like not necessarily having something that I'm building or a project that I'm making, but more like I'm learning this thing that will help me in various ways that I could apply to in the future.
And there's a large group of teachers in this room right now, and I think I think what you said is going to resonate with everyone that's taught any amount of time. You know, it's like, okay, how do I get them from going, let me get this so I can complete this assignment, to how do I get this to fully understanding and then applying it in so many different ways. And it kind of sounds like what Andy was talking about with, hey, we're problem solving. We're not necessarily straight coding just to get the program up. So really, really powerful answers there, guys. I appreciate those. All right. And this is kind of the main event. This is the main question here. Is there anything else that you want, you know, your computer science educators to know, specifically the ones that you had before college? Let's start with Sebastian.
Sure, definitely. Something I've learned, especially being more senior as well, is just having patience, because computer science, everyone, a lot of people handle it differently. It's definitely one of those subjects that's just so much newer within our world. Like, you think of things like reading, writing, math; those have been done for, almost thousands of years, in humanity. But but computer science is such this new concept in the grand scheme of things, and everyone handles it differently. So the best thing you could do, especially as an educator, is just having that patience and understanding that everyone goes at their different pace and is going to have their own struggles going through with computer science. Or even right now, I work with a lot of, especially my master's program, I work with a lot of great, intelligent people, but so with having that, but that's within a medical, background, not within the computer science. So sometimes it just takes time for people to adjust and find out what their strengths are.
Thank you. Annie.
Yeah, I very much agree with that. I think patience is super important. Um, for me, I like went in, I was not as interested in CS as kind of everyone else. So I think I'm kind of bringing in that perspective. So in terms of, if you have students maybe that are taking it as a requirement, taking it whatever, not just solely because they're interested, something that meant a lot to me in the very beginning was how you could apply it to other things. So like, I always use the example of Excel because that's what I've done the most work, and I haven't done a lot of coding. But well, obviously what people have been saying about problem solving is super important. I think it's super helpful and engaging to connect that problem solving to things that you could actually use in your life. Like, hey, here's this problem that you actually have that you can use Excel that will make it easier. I think that was a big draw when I realized how much it's not just coding, making video games, if that's not what you're into, or whatever it might be, kind of applying it to as many different sects as possible to try to bring as many different people in, because I think there's very much a vision of what computer science is. And I definitely came in not understanding how useful it is and how many different like areas it could be applied to. So I think emphasizing that there's a use in learning it, even if you're not going to go on to be a CS major.
Yeah, and I think if you were in our opening session and you saw when Jeremy spoke, the CEO of CodeHS, and he spoke about the mission of CodeHS, And then at the very bottom was that tagline, which was read, write, code, right? So all three of those things kind of touch a variety of areas. So it doesn't really matter if you're focused, if that's going to be your focus past that class, or if that's going to be your career. It's still like a valuable skill to have.
Yeah,
Thank you
absolutely.
for that. Jack.
Yeah, I think that one of the most valuable things you could do as an educator is embrace the process of creativity when it comes to solving problems. I remember I was in my CS at my high school. I like had to petition for it with like 5 students, and we got this teacher who was out of the industry for 20 years, and he taught us to us, and that was my high school CS experience. But I remember it was very rigid. It was very like, this is how you do it. And what I learned when I went to university is that the best, most valuable educational experiences for me were when the teacher was like, hey, you found that other way to do to solve the problem, like go for it. Tell me how it worked. Like report back to me if it worked. And especially when I'm like when I'm in like the lab section with students and they're working together trying to solve these problems, that's the part of the process in computer science that I think is most important. Like making sure that students feel like they not just feel like making sure they know that they are capable of coming up with innovative solutions that even sometimes like the professor or like me won't ever think of. And lastly, I think it's very important for those conceptual things to make it exciting. So like we're learning or the students in the data structures class that I'm course assistant for, they're learning about data structures called like linked lists and binary search algorithms for trees. And the way they're learning it is by building this like movie database with actors, and it has like a whole app where they can like search for an actor using the algorithm that they implemented. And it's just really fun being able to like, here's another thing, analogies are really valuable. Being able to just like think on the spot of an analogy is incredibly valuable for a student. I had a student send me a message from a student who was in the course last year, and they were like, I just wanted to thank you. This tough thing this tough concept, I've got it down because of the analogies that you gave me last year. Really like they're incredibly valuable, and I highly recommend using tools like that.
I think some of the teachers, I can't see their faces, but I can imagine they're thinking, wow, I got some teaching strategies to go back with my classroom. So really, really appreciative of that as well. And Charles, I believe you're the last person who has not answered this question, so don't want to skip over you.
I feel like my other panelists covered a lot of the big stuff, but I wanted to like wholeheartedly agree with what Annie said about reaching for examples in computer science that are like outside of programming and computers literally. And I think honestly, sometimes the further out the example, the better. I remember looking back, I had a book of like the internals of a bunch of like common machines, I think from when I was a kid. And I remember looking back on a diagram of like a mechanical parking meter and the way that it like measures what coin it got by like its weight and how that trips various like tiny internal mechanisms in different ways, and the coins roll different ways when they're passed into the machine. And then realizing that assembling a system like that is a kind of programming was kind of a big revelation for me. In my theory of computation class, we're not doing any programming. We're being asked to draw diagrams of a discrete and non-deterministic finite automata, and assembling this diagram using only circles and arrows and pencils and paper is also kind of programming. And so I've heard the sentiment like, computer science education is super important because computers are everywhere now, but computation has been everywhere long before everyone had a smartphone in their pocket. And so it's it's hard to see because so much of the discussion and the education around computer science has come from the prevalence of, actual computers everywhere. But it's been everywhere for a long time. It just wasn't as easy to see. So reaching for and accessing and talking about the examples that are far away from, video games and programming generally, is a huge help, especially for the students that aren't really that interested in that, and are looking at something else.
That's amazing. Thank you so much. All right, so we're back down to a little bit under 10 minutes. You guys have shared some amazing advice, some amazing background. But we'd like to know, like, what's next for you coming up? Let's start with Jack this time.
Yeah, it's a great question. So I'm graduating from Binghamton University in May. So looking forward to that, graduating CS. And then I'm very excited that at the end of the summer, I'll be working full-time at CodeHS as a
All
software
right.
engineer.
Awesome. What's on your radar, Sebastian?
So for me, I definitely plan to continue to develop more of that hands-on experience working with different data sets and within clinical information. I'm not sure long-term how much I would continue to use CS, but I definitely enjoy it as a skill to have. I mean, I still have plans to attend medical school in the future, so I understand maybe I might rely less on CS, but I just think being able to draw from different experiences and different skills really has helped me develop me as a person as well. I think even if you have someone who's not interested in CS like at all in a future career, I think it's just a good thing to have and fall back on. Like I think to my experience within the military, you have a lot of people, they're infantry officers, what you would call grunts, and there's sometimes those are some of the most, well thought out, best thinking, most educated people I've met within my career.
Excellent. Jack.
I answered this question already.
That's the second time I've done that, guys. I think next time, and I hope there is a next time, coffee all around. Annie, I am so sorry.
Yeah, so I'm a freshman, so I have a lot of classes ahead of me. Gonna keep going with this operations and analytics major, so I'll be doing a lot more Excel. I believe I'll be doing intro to Python, a lot of data visualization and kind of understanding how all the numbers behind all the business stuff is computed and displaying it in a way that is comprehensible and makes sense. Yeah, so I don't know what that'll look like in my career, but definitely a lot of learning ahead of me.
And Charles?
For me, it's also powering through this last month and graduating with my CS degree. And after that, I know I want to be, I've always known, or at least, okay, always, at least since the beginning of high school, known that I wanted to go into software engineering or game development or just working with code and making things generally. And so while I'm still looking for where that's going to be, wherever I end up, even if it's in my spare time, I just kind of want to code stuff. It's just really fun to see, again, to use the Frankenstein analogy, see your creation come to life.
Yeah, and a little bit of peek behind the curtain to you guys out there. Both Jack and Charles, as interns, produce. Okay, they weren't just there learning; they were actually there producing. I would almost say from day one. But yeah. All right. Before we get to the survey, I know we're down to about 4 minutes. I do believe we have some questions. So if you guys are open to answering a couple of questions from our teachers, that would be great.
Mark, I have a
So-
couple.
Oh, go ahead. Yeah.
I have a couple that I can share that I think are really relevant and timely. One is, I'm going to put two questions together. How has using AI changed some of your learning in college? And what is your advice to students and teachers regarding the use of AI while they're learning to code the first time? Is it a tool, or do they need to master some basics before using it? So what are your thoughts around that?
Uh, oh,
Who wants to go first?
You first, Charles.
Oh, sure. I haven't used it too much, personally, but that's also because it hasn't been as applicable. For the main use for AI in terms of like coding is asking it to generate, functions and code snippets and various sets of instructions for you real quickly instead of having you type them out. Not very helpful when you're trying to sort of assemble an automaton for theory of computation. It's kind of abstract. But generally, it's the kind of thing that makes for a powerful tool once you know what it does. It's a whole. I have a class on cybersecurity, and there's been a whole topic of like, yes, I can ask a large language model to generate me the function that I want, but I still have to know computer science enough to know that it works, in a way that works for my application, doesn't take up too much resources, doesn't clash with other functionality. And then especially for cybersecurity, I have to know that it's secure. That's a whole separate concern that requires a kind of thinking that simply assembling, syntax in the language in the right order can't accomplish by itself. It's the kind of thing I think that actually gets more useful the more you personally know about computer science, at least at scale. And if you just need a couple lines of code to print out something in your terminal, you could probably just ask a model to generate that without prior knowledge, but then it would also only take you about 30 minutes to gain that prior knowledge. So it is very proportional to both your task, and then the complexity of what you can ask it only goes up as you get more knowledgeable, I think.
Great answer. Annie, what are your thoughts?
Yeah, I love that answer.
Yeah, absolutely. One thing I think that is important that my operations analytic teacher right now really emphasizes is that AI is going to continue to exist in the future, and especially in something like CS, for a teacher to tell their students, absolutely not, you cannot use ChatGPT, like to completely ban it, I think personally does not make sense. I think that there is some responsibility on the teacher now to teach the students how to use it accurately. Like we used an example the other day of we asked AI, we were doing a pricing model on whether or not we should increase the price, and if so, how much of a product based on a whole bunch of data. And by asking AI whether or not we should raise the price, it gave us a bunch of categories that were very broad, very general, kind of vague. But then when we realized what our answer was, later on, we had a more complete answer. It involved every part of that ChatGPT answer just applied to this. So it was a great example of ChatGPT is a great place to start. It's good at generating ideas. You have a quick question, it's a great place to go. But it has to be taught that it's not going to give you, it's not the end all be all. It's not, you can't type something into ChatGPT and expect to answer a question perfectly or solve a problem perfectly. But that if you know how to ask it questions, if you use it right, it can be a super great tool, I think, especially as a good starting point. So I think overall, teachers have, in this field at least, have some responsibility to teach students how to use it accurately, and how that looks in their classroom is totally up to them. And some teachers are more okay with it and less okay with it. But I think saying, hey, you can't use it at all, I think is kind of a little bit counterintuitive.
Love that answer, Annie. Yeah, it's a tool. Thank you for sharing that. Jake or Jack, what do you think?
Yeah, so when I'm walking around the lab section that I have, so there's like 30 students. I often see ChatGPT, and the university I'm at has a policy against that, but kind of like unofficially, all of the instructors have kind of made it that they're not going to go like say like we see ChatGPT open, you get a 0. Like when I've been in classes, professors have said this is a tool. Like it's not okay to, if you have a programming project, to have ChatGPT write all your code. But it's a great tool to be able to ask questions about conceptual things. Another thing I've seen instructors do is they've kind of changed the style of their teaching to make it so that it's not like your test isn't like write a function in Java to do this, your exam will be on paper, pen and paper. It'll be like a short answer question on like conceptually, like how do you do this? How do you solve this problem? Or even it'll ask you to write pseudocode, like code that isn't with any programming language. Like, tell me in plain English, how are you going to solve this problem? And I found that that's incredibly valuable compared to like just teaching students like Java, for example. It's way more valuable, like what the Java is communicating and what you're telling the computer to do to solve your problems.
Yeah, I love that. And leaning back into pseudocode and problem solving that way, and then also actually handwriting things out. I think that's fantastic. Sebastian, we've got just less than a minute left. Do you want to add your final thoughts there on that?
Sure, yes, I'll try to make it as quick as possible. So yeah, not to repeat anything, but yes, definitely I'm more on the side of use AI as a tool. But don't rely on it too much. Definitely take advantage of it. I mean, I could think of experience. My brother-in-law, he works at Salesforce as a software engineer, and he loves AI. He's a proponent of it, says it's a great tool. And so would I as well. Obviously, in the field of healthcare, it's something, especially my master's program, we're looking at as well. AI is a model to like help us look at different things. Humans are prone to error, but so are computers as well. But how can we kind of make it so they can help us more and better, detect things? Radiology is a lot of just looking at screens and seeing what stands out. But if we could have AI to do that for us, it would be definitely beneficial to the world of healthcare and health as a whole.
Awesome. Thank you for that response. And wow, what an amazing
Yeah,
session with all of you. You guys, this has
yeah.
been, go ahead.
I was just gonna say, so many thoughtful answers, and you guys are so impressive. I know you hear that often, but thank you so much for your time. I know we didn't get to everyone's questions, but again, I speak for everyone here in saying thank you for sharing what I think is kind of one of the most important things for teachers to hear is how are you affecting your students? So for everyone else, we're a little bit over time, so if you can go ahead, go back to the lobby and maybe join your next session, and to our presenters. Loved having you guys here. Appreciate it.
Thank you so much for having us, and thank you teachers for doing what you're doing. Y'all are awesome.
Thank you all.
Thanks.
Seriously, that's how I know. That's how I knew where to start.
And then for those of you leaving, don't forget the survey. So make sure you go ahead and click on that survey. That'll also allow you to get that digital swag back as well.
Yeah, and the survey's in the chat. Previously, I think we told you it was going to be in the lobby area, but it's actually, I just tossed that link in the chat. But quick round of applause for all of our panelists, for Mark, for facilitating. Thank you so much. Thank you for joining us today. So we'll go ahead and close out this room and then go ahead and select your last session. We hope you have a good rest of the conference. Thank you, everybody.
Thank you.